Welcome to a new test and teardown video. This time it's a radiometer from the Danish company in Copenhagen. And this one is called a Polymeter RV21b. And this polymeter just means many things meter. So what this is, a multimeter. Today is what we call a multimeter. So I think that is a really funny polymeter. You probably haven't seen this before. So what can this thing do? Voltage, positive or negative DC voltage, AC voltage, resistance and current. We got a test generator. We got different inputs for either AC voltage, positive or negative DC and current ohms. And up here there's another little trick. Here I believe is the high voltage input. And we got resistance adjustment and the zero on the meter. Of course, this one is fully tube based. So that is why you will have these adjustments, because there will be a lot of drift and stuff to calibrate all the time. And since this is the 21B, I think it is from the start of the 40s. The C version is from 1951, and that is a known fact, but I haven't yet gotten to the schematic of the A and the B versions. The A versions, by the way, is always in a wooden box and a round meter, so it's much older. And yeah, this is of course the B version, so I better open and do a full inspect first. The first thing to worry about is the battery. So there's an offset voltage battery, and why? I really hate when they do this, but that is how it was in all these meters back then, and you access the battery here from the bottom, and that is a smart way. In the later models of the different voltmeters, radiometer, they put the battery inside, and it's completely hidden from outside. You can't even see it anywhere. So they had a perfect good solution, and then they dropped it for whatever reason. So you push and then you turn, and then you access the single cell. So I better see if this one is leaked, but so far it looks nice and fine. This one was updated or modified, improved a little bit, I would say. Look at that, a modern IEC connector and a little funny hole. I can see the marks from the making that hole, and there's a little adjustment here and stuff. Yeah, but we definitely need to open and inspect anyway. Oh, it's a little bit dusty. I was lucky to score this yesterday, together with a big lot of other cool things. So again, a million thanks to all my sponsors and supporters, everybody who calls me and say, hey, come and fill up your car with all sorts of cool things. We're cleaning up, we are fixing stuff, and you need to go and get some cool things. And here is the high voltage isolation thingy, 2 mega ohm resistors. So I bet this has something to do with the higher voltages or something like that. Why would you have it like that? So I got the battery out. Look at that, 1.45 volt. I mean, this is like brand new, and I am a little bit in shock because this one I think is rather old. There is no indication. Sometimes you find a little stamped in year or something like that. So we need to ask all our friends, please tell us if you know how old is this. Could be fun. But I mean, to find full voltage, I mean, it's probably better to put this back for another 20 years instead of putting in a brand new Duracell or something. You're going to have this leaked in a few years. So it's much better put this back in. This is what I will do. This is so amazing. Let's enjoy this fantastic unit. All the interesting internal parts here. So that will be all the different ranges. So we got high value and low value resistors, obviously for voltage and current ranges. And it was definitely repaired a few times and also modified. Look at that. What you see here will be diodes for the high voltage rectifier, and that tube is of course not mounted. And there's another tube missing. We can probably, yeah, here we go. We can see that hole down there. And here is the EB4, that will be a dual diode that is missing. And the EC2 is a dual power diode that is missing. And then here at the bottom, where this tube was supposed to be, look what they did. They put in two diodes where this, yeah, here's the other one. So that means we're saving a lot of power by using modern diodes instead of tubes. So I think that is good. It also saves a lot of heat build-up in here. You can see a little bit of modified resistors for some of the ranges, probably because they overloaded or something like that. It looks a little bit like brown. I'm a little bit curious to see what happens. I don't see anything widely burned or anything that will delays me or something like that. I should definitely be able to power this up. Look at this super electric condenser. High voltage, definitely. Oh yeah, by the way, this resistor here, the idea is this is just a storage facility, so it's not going to get lost. And the reason I know that is, look at that. It just goes in here. And this is just some chassis mounted. So it's not doing anything at all here. It's just mounted for storage. Oh yeah, look at that. This we need to fix. Very well done with this modification. Ooh, look at that, some nasty. But this is really, really old. You can imagine this one is from, yeah, the start of the 40s. Oh yeah, there's another cool thing to mention, and that is the meter. This is not the original meter. And how many times do you think the meter was replaced in this unit? I don't know if you can count, but that will be a lot of replacements. What the heck? Why do we have that many holes here? A little bit less. Oh, maybe they could reuse some of the holes, but that definitely something is going on here. Oh, that is some crazy. And of course this meter got high and low ranges. This is a special meter for voltage and for current. So we got several winding systems in there. So that is why you have these extra connections to the meter. So it is a rather special meter. And here we got the EF6 tubes. And that is all there is to find in this. Now we have removed the other two tubes. So yeah, let's try and see what happens. Will it blow up? Will it work? So let's try and power this up for the first time. I think I will see what happens real slow. And I put in a new fuse and it's now nicely connected. That is a 100 volts and it's using 3 watts. And then let's just crank it up real fast. That will be 200 volts, 8 watts. And then we have some response and it's 230 volts using 10 watts. And we are in DC volt mode. And it's nice and stable right here. I didn't connect anything yet. I think this is 50 volts DC. So this one should not have any effect because this is the ohms. This should be the 0. So I should be able to put this to 0. So if this is the 50, then I can go to the 15. Aha. Then it is more sensitive and then I can adjust for 0 again. So if this is 15 for full range, then here we got 12 volts in a second. Let me turn on 12 volts and let's put the 12 volts here. And it should go, oops, it's not going to the 12. So 9, 10 and a half is what it says. Maybe, I don't know how easy is this to see, but it is not reading exactly what I expected. And we are going back to 0. So there is some missing gain in the tube. So maybe there is one of the adjustments. We got a lot of trimmers to adjust the different ranges and all that kind of stuff. So now I'll see if I can find a schematic for the, I don't have the schematic for the B version, but I have a C version. Maybe I can get a little glimpse of the idea. Now it is maybe more like this. This is not too good. Let's try the other range. This is the 5 volt range. So what if I give it, so if we have 5 volts, 4 volts should be what I want, like that. So let's adjust for 0. So 4 should be right there. And we got also, it's amazing how slow it is. See, it's still getting up. Well, well. And then, look at that, it's really funny. It's almost like it's alive. But anyway, that is how it is so far. Let's see if what happens if I am in the, maybe I need to massage the switches a lot more. So this is the AC mode. And look at the instability here. And what if I give it some DC? So there's a blocking capacitor. Here it is. This is the AC. No lock. So of course you need to input some AC, but this is completely unstable. There's probably a million things wrong with this one. And what else can we try? So this is the, oh, okay. Look at that, pretty stable, huh? Okay, I did not clean anything. So then, there you have it. You adjust for maximum on this one, I guess. And then you take the cable and then you short it and then you zero with the other one. And then you go back and then you adjust a little bit more. See, I need more gain. Ah, now it's coming. Like that. And there you have it. Can you imagine spending that much time on calibrating every range? So this is this range, and then I play a little bit more. Okay, this one is probably... Okay, see what's going on here? I need to massage this as well. And then it just goes up and up and up. Yeah. This unit is very, very old and need a lot of attention. So now it is not... Okay. So I've been playing with this for a few hours because what happens with really, really old tubes, they get low gain. And if you just leave them burning for a few hours, then they will restore. And I've seen this many, many times in old equipment. So let's try and get a little bit closer to the screen so we can see what is going on here. So I am in the 5 volt range, and I come with 4 volts from my power supply. So let's try and experiment a little bit with this zero adjustment here. I have it as accurate as I can, and then I try and plug in my 4 volts. And I mean, I would say that this looks a lot like almost 4 volts. I did also crank up the adjustment potentiometer. There is one here at the side. I cranked it all up all the way, and it was only going about 3.5 or something like that. And then the last 2 hours, it's been slowly moving. So I think I'll just leave this for a couple more hours and then see what happens. And this is the 5 volt. Okay, let's try something funny. Let's go to 15. So this is the 15. Look at that. So it's also showing 4 in this range, and then we can crank it up. Before I was using 12, and see up here, we need a few more volts. So that's probably some of the resistors or something like that. So this is the 50 volt range, and we have now, see, it's way too little. Then I can go to 30 volts, and here is 50 volts range, and this is 30. So it's saying what, 26 or something like that. So it's way too low in all the other ranges too. So I need a lot more gain. And this is the problem with really, really old equipment like this. It's using rather special tubes. It's using these EF6 tubes, and I only got one in my little tube list. I'll try and see if there's a little bit more gain in this one, just for fun. We got, of course, 2 of them in this unit, and they are coupled as a balanced amplifier. Here is the schematic for RV21c. So this is a model that was after mine. Mine is the B model. So of course I would expect a few minor details to be different, but I think in the big overview this will definitely be useful. I haven't so far seen the big differences between my unit and this schematic, so I think it's pretty good. If we look a little bit in the upper left, all that I have marked here is the mode switch that selects between positive and negative DC voltage, AC voltage, resistance and current. And there will of course be a lot of rerouting of measurement signals and all that kind of stuff. And just under that switch section we see a tiny little dual diode. This one is the diode tube, the rectifier tube used for AC measurements, and in my unit it is replaced with 2 diodes. If we look at the bottom left corner, we see all the ranges. A lot of resistors here for the different voltage, current, and all that kind of stuff. And we see all the low values. That is, of course, for current measurement. Also note this little red marker here I set around the 1.5 volt battery, and that is of course for resistance. We need to input a known value, and you can of course imagine if this volt is like 1.5 one day and 1.4 another day, you could of course imagine that your readout will be a little bit off. But the whole idea with this meter is you calibrate it for each range, for full and for zero, for open and for zero in each mode. So that means the amount of voltage you have available on the battery isn't really such a big part anymore of your measurements. So that is pretty smart. If we look at the zoomed in snip here, we see the 2 EF6 tubes coupled in a differential amplifier mode. And if you are very, very familiar with tubes, you will see that it is indeed a pentode tube, but they have coupled it in a way where they fully, disable the other 2 grids. So that means you have a triode coupling. And we see the 0 point, the 5K potentiometer that is in the front. This is of course our 0. And then we have another potentiometer to the left. They call this it's a 10K potentiometer. This is the sensitivity, and this is actually amplification. So what I think you need to do is adjust the sensitivity or the amplification in voltage mode, in that mode where you need or want the highest accuracy. And of course you expect it to be pretty good in all the other ranges. My meter is far from that. I can actually tune mine into a very good readout in only one that range I'm using. So I expect I need to spend quite a long time on resistors and switches and all that. It did really help a lot cleaning all the different switches and potentiometers. So at least I have everything nice and stable now. So now I changed the left tube. Oh, this is nice and warm. So this was the left one. And I have adjusted 0 like that. And let's try and go a little bit closer. And here we go with the 4 volts again. Look at that. Now it reached 4.2 something. So this proves that there's a lot more gain in a new, there's no such thing as a new tube, but this is a different tube. So now let's try the 15 volt range. And it's of course reading a little bit more than 4. 4.5 or something like that. So let's try and give this now the 12 volts and see how close we're getting. But of course we know that there's something with the resistors as well. So, but it is definitely better. So let's try the 50 volt range. And there's another thing that we need to remember. When we change the ranges, we need to just double check the 0 is now again perfect. And here we go in the 50 volt range. That will be the 12 volt. That seems to be pretty good. And let's crank this all the way to 30 volts. And then, oh, we need a lot more here as well. So there's plenty more hours of entertainment left in this unit.